Alright, so this video is talking about Newton's second law. But first, before we get to that, let's review what we have talked about the other day. We went over the force of gravity, and what was called was weight. And we had an equation that allowed us to calculate that. It's Fg, which Fg is weight, equals mass multiplied by this g value, which g is acceleration due to gravity. The units for force of gravity is newtons. For mass, it's measured in kilograms. And then for the acceleration due to gravity is in meters per second squared. So if I have, and like I said, don't forget we have a quiz on this tomorrow. If I have this equation, Fg equals m times g, if I wanted to solve for Fg, I just take my mass and multiply it by my acceleration due to gravity. If I wanted to solve for my mass, I'll need to divide both sides, if I wanted to solve for mass, I'll need to divide both sides by acceleration due to gravity. If I wanted to solve for my acceleration due to gravity, I will need to divide both sides by my mass. So G, acceleration due to gravity, would be equal to the force of gravity divided by mass. But you plug your numbers in, use algebra to solve those. Just remember for tomorrow's quiz, you need to memorize this equation, Fg equals m times g, and you need to memorize that g on Earth is 9.8 meters per second squared. Now, on to Newton's second law. So this is the guided notes you should have that you should follow along and fill in as I fill these in. Alright, so when we talk about Newton's second law, what is that stated in words? Well, it says that an unbalanced force results in an acceleration. Alright, so if an unbalanced force results in something accelerating, what about balanced forces? Balanced forces is when all the forces around an object balance each other out so that your total force would be zero. So if you have a balanced force, there is no acceleration. Acceleration would be zero. Okay? And also, if something moves at constant velocity, that means that there is zero acceleration. Therefore, you must have balanced forces. And we'll look at that more in depth in a few days. So stated as a formula, I need to know that it says that F net is equal to my mass times my acceleration. Now, what is F net? Let's go up here and let's write this down up here where we have room. F net is the sum of the forces acting an object. Alright, so there's individual forces that act on objects, there's applied forces, but sometimes, say if two people are, one's pushing on a box, is pushing, this way on a box with, 5 newtons of force, and then somebody else is pushing this way with 5 newtons, then what would be your net force? Well, those vectors are in opposite direction. Remember, force is a vector quantity. When vectors are in the same direction, we add them. When they're in opposite direction, we subtract them. That would just be, the F net would be 0 newtons in that situation. Now, if they were both in the same direction, I would add them and get my F net would be 10 newtons. But for my equation, Newton's second law, that's not just equal to force equals mass times acceleration, it is F net, the net force. Make sure you make that distinction. Now, F net, what's the unit's going to be for that? That's going to be measured in newtons. My mass is going to be measured in kilograms. And then my acceleration is going to be measured in meters per second squared. And don't get this confused with our Fg equals mg. That is the force of gravity equals mass times acceleration due to gravity. This acceleration is not acceleration due to gravity. This would be how fast you accelerate in the x or y direction. It's not how much the earth is pulling on you and how fast you're accelerating down or falling, but due to the force of gravity. And we also need to note that 1 newton is equal to something. There's a reason we call it a newton. It's because it's equal to actually 1 kilogram times meters per second squared. So to shorten that up, we call that a newton. So we could, if we're talking about force, we could always refer to, the force of this is 20 kilograms times meters per second squared. But that's just a lot to write, so we short it up and call it a newton. But make sure you know this. Put a big star by this. This will be a test question. Now, as we look at this first problem here, this is a Newton's second law problem. We're going to go through just like we do all of them, write our givens, write our unknown, and then substitute and solve equation. I'm going to go through and underline what the problem gives me. A 5.0 kilogram block. What's that telling me? It's telling me a mass is pushed to the right along a frictionless track with a net force of 10 newtons. That's my F net. What is its acceleration? So acceleration is what I'm asked to find. I'm going to write down my givens. Mass equals 5.0 kilograms. F net equals 10 newtons. And remember, it's a vector quantity, and this one has a direction. It's 10 newtons to the right. And then once we solve for acceleration, that's my question mark. It's going to have units of meters per second squared. My equation is next. Remember the guess method, givens, unknown. Equation, which in this case is F net equals MA. M times A. And then I'm going to substitute and solve. My F net is 10.0 equals my mass is 5.0, and then times acceleration. Like at this point, if I want to solve for acceleration, I need to divide both sides by 5.0. Cancels out on that side and this side. Acceleration is going to be equal to 10 divided by 5. And then when I punch that into my calculator, it's going to give me 2.0. You need to go around these to 2 decimal places. So if it's a whole number, just say 2.0. And then my units of acceleration, meters per second squared. Show my work, put a box around my answer when I'm finished. Okay, let's look at the next one. problem says a 650 kilogram car is telling me a mass, accelerates at 4.0 meters per second squared south. It's giving me acceleration. Wants me to find what's the net force acting on it. Alright, so right now my givens, my mass is 650 kilograms. And remember, if this was to give me grams, I need to convert to kilograms by dividing by 1,000. Always make sure you check that. On some of the on the worksheets, some of them are in grams. You're going to need to pay attention. Acceleration is 4.0 meters per second squared south. And I should have in the last problem, going back just a second, I should have said in my answer 2.0 meters per second to the right. If it gives me a direction, I need to show that. Acceleration is a vector also, it has a direction. Alright, back to this one. What is the net force? So I'm solving for F net. Force unit has units of newtons. Next, my equation. F net equals ma. Plug in. I don't know what F net is, so I'm going to leave that as F net equals 650 is my mass times 4.0. You punch that into your calculator, and it's going to give you, I believe, 2,600. And you could leave that as a whole number, or you could say 2,600.0. That's one decimal place, and that would be newtons, and it would be south since it gave me a direction. Okay, on to the next one. Problem says a 2,300 Newton, that's important, it's telling me newtons, that is net force, so that's my F net, causes an object to accelerate at 4.3 meters per second squared, that's acceleration. What is the mass? So it's telling me F net equals 2,300 newtons. Acceleration equals 4.3 meters per second squared. And what is the mass? Units per mass are kilograms. Next, I'm going to write my equation. F net equals m times a. Next, substitute and solve. F net was 2,300 equals my mass, leave that as m, times 4.3. If I'm going to solve for m, I need to get it by itself, so I need to divide both sides by 4.3. It's going to cancel on this side. So my mass is equal to 2,300 divided by 4.3. Once I work that out to one decimal place, I should get 534.9 kilograms. Put a box around my answer. Okay, next, when it says to find F net when two forces work together, then we simply add them up. If they work in the same direction, we add them up. So look at this problem. Stan and Kyle are pushing a 75 kilogram sled. What's that telling me? It's telling me my mass. Along a frictionless ice rink. Stan pushes with 55 newtons and Kyle pushes with 45 newtons. Find the sled's acceleration. So what this is telling me is that I have this sled and it's being pushed to the right. I guess I assume it's to the right, and it's being pushed, and I'm going to draw whenever we in the direction it's being pushed by one of them with 55 newtons, and then the other one's pushing with 45 newtons. So my net force is I add those together. 55 plus 45 would equal 100 newtons, since they're in the same direction. And then the mass of the sled was 75 kilograms, and I need to solve for acceleration. And I know the units, I'm solving for meters per second squared. Next, my equation, F net equals ma, m times a. Now I'm going to substitute and solve. F net is 100 equals mass was 75 and times a. I need to solve for a. So I'm going to divide both sides by 75. And then my a would be 100 divided by 75, which would give me 1.3, round to one decimal place, 1.3, and then units would be meters per second squared. Don't leave out the units. Otherwise, it's just a number. Okay, last problem. It says to find F net when many forces act on an object. You know, if they're in opposite directions, we're going to take the winners minus the losers. All right. So it says the Batmobile exerts a force of 85 newtons east, while friction pulls back on it with a force of 15, I should say newtons. Friction always opposes motion and an applied force. If it has a mass of 12.5 kilograms, and that's telling me my mass, what is its acceleration? Alright, so I'm going to draw a what's called a free body diagram to show the forces. It's telling me that this way, I guess we could take it being east, there's an 85 newtons of force. And then opposing it is 15 newtons. Now, if vectors are pointing in opposite directions, we subtract those. So my net force, in this case, is going to be 85 minus 15, which would give me 70 newtons. And then it told me that I had a mass of 12.5 kilograms. And now I want to solve for acceleration. And that's going to have units of meters per second squared. Next, I'll write my equation. F net equals m times a. Plug in my numbers. F net was 70 newtons equals my mass, which is 12.5 times a. I got to get a by itself, so I'm going to divide both sides by 12.5. So acceleration is going to equal to 70 divided by 12.5. So when you punch that into your calculator, you should get a number that rounds to one decimal place to 5.6, and then the units would be meters per second squared. And that's it to work in these problems. It's simple 3 variables in there, just like our earlier equation, FG equals mg, that, pretty simple algebra to solve for these.